Hey, welcome back to Dirty Shirt Workshop. Today I am repairing two of my LED light strips for the shop here. I had two of them. This is what the power supply looks like. It just burned out. I had this problem with one of these strips, one of the first ones I bought, and they covered it under warranty. They gave me two new power supplies when I only needed one, so that was great. I did order another set of those to have on hand, and I've repaired the lights, but I really don't like what's going on with them. So these are by Shine Decor. It's Chinesium. They're on Amazon. They are really nice lights. I love them. This basically rectifies to DC, so you don't have any flashing or flickering or anything. It's constant current, which is really nice. The lights themselves have been great. But I was really concerned about these power supplies because they get really dang hot. So I took one apart here, and this is what it looks like. I'll throw a close-up on there right here in the video. So this chip, I can barely read the numbers on it here, but after I took the picture and looked at it on the computer, I could actually read all identifying marks on it. Did a web search for it, and although I couldn't find the exact chip, because off-brand custom Chinesium chip, it's almost the same number. So they have a manufacturer's number and then like a part number, and it seems like 8M is a full wave rectifier, 800 watts. So on the label here, I figured that was what it was going to be because it says AC in, DC out, and then it says it's that the DC out is between 100 and 120 volt DC. So if you rectify AC 120 volt, you get about 108 DC out. So that's kind of what I figured was in here. They also have derated it to 600 watts. Why? So two reasons. Well, one reason really. It's kind of two reasons, because there's this plastic shroud that goes on the outside here. I cut that off, and then inside there is another plastic shroud, and this has in it the rectifier chip, and this is fully cast. So they make this circuit, hook the wires up, hold this in a mold, and then inject plastic around it so that you can't do what I'm about to do, which is reverse engineer this thing to fix it and make something better. So what am I going to do? I found online these chips. I actually ordered these from Mouser. You can get them from DigiKey too. These are $1.11 a piece. I ordered 30 of them. Getting replacement power supplies is like 40 bucks. So I can make 30 of these things now if I want. They just take AC in on the center prongs, you get plus and minus out on the outside prongs. Now, because these are LED lights, they are diodes, which means they're only going to light in one direction. So I actually took a working version of this, hooked it up, and found out with the label up, basically with the label and the lights up, if you look at it with the lights up, the positive's on the left side. So I have to make sure I wire it that way when I put it together. So I'm going to hook this cord up and solder it on here with shrink tube to cover it up and insulate, and then I'm going to make a heat sink. So I have some 1.5-inch copper plumbing pipe here that came from when I ripped down a wall in the house and did a remodel. There's all kinds of copper drain pipe. Awesome, I hung on to that. So I'm going to cut a piece of this off, flatten it with a hammer, cut the edges, and I'll have two pieces of copper sheet that I'm actually going to bolt to this. So we got this hole here, number 8 screws, if you don't drop them, will fit perfect. So I'm going to use the copper. I got these fender washers that I'm going to put on there, which is dang near as big as the thing, with the copper in between. The other thing I'm going to do is put some dielectric grease in there as basically a thermal compound. Dielectric grease will work just fine for the temperatures this is. You don't have to use like thermal paste like you would for a computer CPU or something. That'd be way overkill for something like this. So yeah, that's what I'm going to do. So let's get going. That can go in the trash. The iron hotted up here and we can solder this down. It doesn't matter what the polarity is on this side because it's AC. Try a roach clip to hold this in place. Might work a little better. Plus it'll help keep some heat out of that chip. Oh, that came out a lot better than the other one. I think I'll reheat the other one. Get started on the heat sink next. I think you'll only have this problem if you have the 150-foot light strips. I got the other sizes and none of those have ever burned out. I think the 150 is just too long. Before I cut this other side off, I'm going to drill this for my screw so that they're even. Close enough. It don't need to be perfect at all. The other thing I'm going to do, I'm going to go anneal this with the torch so that it will form fit this really well instead of having voids underneath of it. Other thing I'm going to do is cut these a little bit with the cold chisel to make fins on them. Oh, that works real nice. Not going to work so good for the other side because I like the little curve. That's pretty sweet, but I can't hold it now. Probably need them more out. I don't know. I've never made a heat sink before. I know what they look like. Fins are supposed to be good. Whatever. It don't have to be perfect. Now this back one I'm going to leave flat. Because what I'm thinking I'm actually going to do, since the track that I have my lights in is steel, because it's that steel sheetrock track, that I'll just put my bolt through that too. So this copper will be in direct contact with that steel and give me a whole lot more heat sink. So that's going to be the plan. Now let's see how this is going to look when I put the screws in. Oh yeah, that's flattening out just the way I wanted it to. Not super pretty, but I think it's going to do the job real well. One thing I thought of here while I was piling all my stuff into a box to take it up there, I ought to see if this actually works as it is. There we go, 111 volts. That's negative. So that way, there we go. Okay, I'm up here where I have the light. Here's my track here. So what I'm going to do, this is a replacement power supply and it works, but I really want to go to this because I know this is just going to burn out on here. But I'm going to leave a little pigtail on here so that that I can reuse this power supply on a smaller strip if I have a light burn out on that. Man, that sucker's hot. That's not good. All right, so this will be about the same as it was over on the bench. Just a little more awkward because I'm floating in midair in a boom lift. So as you look at the strip, the one on the left from this side needs to be the positive. It's okay to stretch this stuff and pull it tight when you're wrapping, but then when you're ready to cut, don't do that. Just let it wrap around and lay down easy like that. Hope I don't drop the screw on the ground. I'll be really mad if I do that. So actually, I don't want the washer now. On that side. Okay, so I'll put that on top. More. Does it still work? Yes, it does. Awesome. Let me bring you in for a close-up. Alright, so the screw comes up from the bottom. I got my bottom piece of copper. Hey, look at this. I'm touching bare steel, not getting shocked. So that's good. And then, so the copper, the rectifier, more copper, and then my nut and washer. So you could definitely make something like this. It doesn't have to be mounted to this, but I wanted to do it to take advantage of the steel to help keep this thing cool. Yeah, this is, it's not really very warm yet, but we'll have to give it a while and see what happens. Well, I think I'm gonna make some more of these and convert the rest of my lights, because this is gonna be, yeah, I'm sure this is gonna work a lot better. It's not even, yeah, it's not warm yet. Let me plug in this other light, check it out. Yeah, the factory one's already getting hotter. All right, I went and had me some lunch. I've left these lights on for about 45 minutes now, and we're gonna see what temperature these power supplies are. Here you go, factory power supply, can boil water. That's crazy. 212 degrees. Here's mine. See if I can find the hot spot. Some of it's only 90. There we go. 116. So this is about 100 degrees cooler, running my version with this heat sink. So I think that's gonna last a heck of a lot longer than the other one. Definitely worth doing. It was $1 for that rectifier and a little bit of work. Some copper I had laying around. I basically have no money in it, and I won't have to mess with this again. Got this one changed out here. See if you'll be able to see this here. Yep, so there's the new one that I just put in, and then here's my other one. So these are doing real good. Regarding LED lights in general, I really believe in these strip lights. They're weatherproof. You can have them out in the rain. They hold up good. I checked throughout the whole shop here. Not a single one of these LEDs is out. There's 5,400 LEDs in one strip, which was 200 bucks. That's pennies for the LEDs. So that's really well worth the money, even if the power strip goes bad. I wish it didn't, but since the power supply went out, we did this, and I think this is gonna be a good solid repair that's gonna probably outlast the LEDs now that it's only running 100 degrees. I mean, it gets 100 degrees just outside, so shouldn't be any trouble. Price-wise, if you compare these to high bay LED lights, I just checked online at my favorite home store. They're about 100 bucks a pop. You're gonna need about 20 of them for a building this big, at least. I would bet. Because this is 104 feet long, 60 feet wide. That's a lot of space if you want to fill it up with light. So like 20 of those, there's $2,000 for the lights, and then you figure all the work you're going to be doing or what you're going to pay an electrician to cut all those holes, run all the wire, set up the circuit, you got your inspector and all that crap. This 4 strips, it's 3 outlets. It happens to be 3 because I had the door down there, so I got one starting on the right side and one starting by the door going into the house. So 3 outlets, some switches. It's hardly anything, and they just plug into the wall. So you don't even really have to have an inspector inspect these lights, because they're just checking the outlet. Yeah, is the outlet good? Yeah, it's safe. Okay, you can plug whatever you want into it at that point. They don't have any authority on that. So if you went with high base, I bet you're probably $3 or $4,000 into it by the time you're done. With this, I got $800 for the light strips, like $300 for the steel, for my little track and some spray paint, and that's it. So it's a lot cheaper, and it's great light. It's all reflected, so you don't have something beating you in the face while you're working. There's other brands of these lights now, lots of other brands. I don't know if any of them are better or worse. I just know they're out there. Some are cheaper, some are more expensive. I don't know what you're gonna get. I like these, except for the power supply issue. I will put down in the description down here a link to the rectifiers that I bought. This isn't sponsored or anything. It's just what I got in case somebody else has these lights or similar lights that use 100 volt DC. You'll be able to do this and fix your lights or make a better power supply if you need to for whatever reason. So that's all I got for you today. I'm going to go check out my other 2 lights. They probably got brown spots on the power supply too, and I'll change them out. Thanks for watching.